All right, let's dive right into this explainer. Today, we are embarking on a journey that is going to absolutely stretch our understanding of both space and deep time. We're looking at a mission that started right here in our own planetary backyard, but is currently hurtling toward an unimaginable, truly staggering future. Picture this. Out in the freezing, pitch black vacuum of space, there is a small, silent traveler just drifting along. And, we really aren't just talking about some old piece of machinery today. Voyager 1 is basically the enduring protagonist in the ultimate cosmic story. Her original mission? Well, it was just to explore the outer planets of our solar system. But right now, she is literally exploring the universe itself. There is this one thought about Voyager that just gives me chills every time. It left the world that built it, and it will outlive even the stars themselves. Just take a second to let the heavy, profound weight of that sink in. Long after our sun has totally faded out, and Earth is nothing more than a memory written in the cosmic dust, this tiny little spacecraft is going to carry a fragment of who we were into a future that we will absolutely never see. So, how did this whole shebang start? We have to rewind to 1977. Voyager 1 launched aboard a massive Titan IIIe rocket just a couple of weeks after her sibling, Voyager 2. Now, you might be wondering, why launch then? It was all about timing. We had this incredibly rare planetary alignment, a once-in-a-lifetime setup where the outer planets were arranged perfectly. It meant the spacecraft could visit multiple worlds using gravity assists. Basically, they used each planet's gravity like a giant cosmic slingshot to fling Voyager toward the next destination. That one clever physics trick took a short mission and turned it into this epic, grand tour of the solar system. Now, sure, Voyager carried a full suite of vital instruments, cameras, spectrometers, plasma detectors, the works. But bolted right to the side of the craft was something uniquely human, the Voyager Golden Record. This gold-plated copper disc wasn't just extra cargo. It was a literal message in a bottle. It's packed with greetings in dozens of languages, sounds and music from Earth, and even a cosmic map using nearby pulsars to pinpoint our solar system's exact location. From day one, there was zero plan for a return trip. This record was engineered to survive the vacuum, the freezing cold, and the intense radiation long enough to tell whoever, or whatever, might stumble across it exactly who we were. Okay, fast forward a bit to Voyager's arrival at Jupiter. Talk about a hostile work environment. Jupiter is absolute chaos. We're talking monstrous wind speeds ripping along at 1,500 kilometers per hour. And the Great Red Spot? That alone is a 16,000-kilometer-wide storm that could easily swallow the entire Earth whole. But the invisible dangers were just as fierce. Jupiter packs this massive magnetic field that whips up radiation belts far deadlier than anything near us. Voyager had to survive this incredibly harsh neighborhood just to steal a tiny fraction of Jupiter's orbital energy, converting it into a massive speed boost outward. But get this, the biggest shocker wasn't even Jupiter itself. It was orbiting right next to it. When looking at the moon Io, scientists noticed something absolutely mind-blowing: active volcanic eruptions. They saw actual plumes rising 100 kilometers high, blasting straight up into space. At that point, we had never seen active volcanoes anywhere beyond Earth. It was a total game changer. And Voyager didn't stop there. She also gave us our first real look at Europa's crazy ice-cracked surface, Ganymede's complex terrain, and the ancient, battered face of Callisto. Next stop, Saturn. Obviously, the rings are stunning, but the real primary target wasn't actually the ringed planet itself. Actually, scratch that. It was its largest moon, Titan. To understand why scientists were so obsessed with Titan, just compare it to Earth for a second. Titan is wrapped in this dense nitrogen and methane atmosphere with 1.5 times the surface pressure of Earth, totally hiding its surface. It's basically a massive laboratory of chemistry and motion, where sunlight breaks molecules apart to create weird chemical rains. But to study it, Voyager 1 had to fly super close. And doing that, it bent her path entirely, slinging her on a brand new trajectory straight up and out of the solar system. So by 1990, she's officially on her way out. But before leaving our neighborhood behind for good, Voyager turned her cameras back toward the inner solar system for one very last look. From nearly 6 billion kilometers away, she snapped the famous family portrait. In that one frame, Earth is just this tiny, fragile speck of light, the pale blue dot. Really think about that for a second. Every human story, every dream, every war, every thought, completely compressed into a single pixel. Right after taking that beautiful, haunting photo, her cameras were shut down forever to save power.
So now, with her cameras off, Voyager is flying blind into the dark. But she is absolutely booking it. 17 kilometers per second. To put that into perspective, that is the blistering speed at which our little spacecraft is hurtling toward the very edge of our cosmic neighborhood.
At that incredible speed, she was racing toward a final invisible frontier known as the heliopause. Basically, this is the exact boundary where the outward pressure of the solar wind, the stuff our sun blows out, is perfectly balanced by the pressure of the interstellar medium pushing back. Now, crossing it isn't like driving past a visible border checkpoint with a signpost. Voyager couldn't see this change. She detected it. Her instruments registered a really sharp drop in the particles coming from our sun, matched by a sudden, massive spike in cosmic rays coming from the deep space outside. Which brings us to a seriously monumental date in human history, August 25th, 2012. That is the exact day our small traveler officially crossed the heliopause and entered interstellar space, the literal space between the stars. She had finally, permanently left the sun's protective bubble behind her. Fast forward slightly, and by late 2026, Voyager will reach a staggering distance of 25.9 billion kilometers away from Earth. That officially makes her the very first human-made object to be exactly 1 light day away. Do you realize what that does to our communications with her? If we sent a command from Earth today, it takes a full 24 hours traveling at the literal speed of light just to reach her. And waiting for her to say message received? Yeah, that reply doesn't arrive until the day after tomorrow.
But here's the bittersweet reality. That long-distance chat, it just can't last forever. We are slowly creeping into what we call the long silence. You see, Voyager's power comes from these radioisotope thermoelectric generators. Think of them as plutonium-powered nuclear batteries, and they are steadily, unavoidably losing juice over time. To keep her running, engineers on Earth have had to play this tense game of shutting down her systems one by one just to conserve energy. Sometime around her 60th year out there, she's going to fall completely silent. But remember, from our perspective on Earth, she won't appear to die. She will just quietly stop answering our calls, moving along through deep space, totally unaware of whether anyone is still listening.
Okay, so this is where things get truly mind-bending. As we leave the timeline of human history completely behind, we enter the realm of deep time. The eons ahead entirely subvert our normal human timescales. We are talking about staggering cosmic milestones, 40,000 years, billions of years, and even trillions of years out into the dark future.
Let's start with 40,000 years from now. Voyager will drift within roughly 1.7 light-years of a star called Gliese 445. Out there, between the stars, the distances are so unfathomably massive that even a spacecraft moving at 17 kilometers a second seems to just crawl. The isolation at this point is profound. Her radio will have been dead for tens of thousands of years. Nobody is tracking her daily progress anymore. There's a very real chance she'll just be a silent relic of a civilization that might not even exist anymore.
Let's push it even further. 3 to 4 billion years from now, Voyager is totally untethered from our solar system. She's just somewhere deep inside the Milky Way, and figuring out her exact coordinates would be basically impossible. But our galaxy isn't just sitting still. Our nearest large galactic neighbor, the Andromeda Galaxy, is currently barreling toward us. When that gap finally closes, gravity is going to reshape everything. The two galaxies will pass right through each other and merge into one massive galaxy. And our unseeing, silent traveler, she will be adrift right in the middle of a billion-year cosmic light show.
All right, brace yourself because we are now pushing the clock ahead 10 trillion years. Contrast our universe today, which is about 13.8 billion years old and full of bright, massive, energetic stars, with that distant future. 10 trillion years is roughly 1,000 times longer than the universe has currently even existed. By then, star formation, it's completely ground to a halt. The night sky is incredibly sparse, incredibly quiet, lit only by the slow, dim burning of tiny red dwarf stars. If Voyager actually survives to see this era, she will literally be older than almost every active star left in the entire galaxy.
But wait, it goes deeper. Beyond the age of stars, we hit some staggering theoretical physics, specifically something called proton decay. This is a potential future where ordinary matter gradually just breaks down. The atoms themselves literally dissolve into lighter particles. It means that ultimately the laws of physics might cause everything that ever existed, even the heavy, gold-plated copper of our incredibly enduring record, to simply be erased by the universe itself. Just take a second to let the absolute terrifying scale of deep space and deep time sink in. The idea that everything we are, everything we built, could just eventually dissolve into nothing. But, it brings us right back to that golden record. It carries this incredibly simple, hopeful message that in the vastness of the cosmos, life looked up and reached out. It's a beautiful thought, but it leaves us with one final haunting question to chew on. When the universe eventually erases even the smallest star,